Let's understand a very important theorem. Right now, we are just understanding the theorem and its application. We are not going to prove it. We'll prove it later. First, let's understand. Every theorem has a statement. So let's take up this statement. The statement says that if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in proportion. Now, from any statement, if it contains two words, if and then, those are two keywords. If it is there, that means we understand that whatever is between if and then, that's a given. And whatever is after then, that's the to prove, that's the result, right? So let's see whatever is there between if and then. If you see that a line parallel to a side of a triangle. So first we understand we need to have a triangle. So we take a triangle ABC. It is a line parallel to a side of a triangle. So we want a line which is parallel to one side of a triangle and intersecting at two distinct points. That line has to intersect at two distinct points. So isn't that this line L is parallel to side BC and is intersecting AB and AC at distinct points D and E. So this is what is given. That means this is what we draw. That means we are saying that in triangle ABC, we have a line L which is parallel to side BC. That's the given information. So what happens? What's the result? That means after then, that's the result. What does it say? The line divides the sides in proportion. In proportion means equal ratio. That means this line L divides the sides, that is side AB and side AC in proportion. That means the ratios are equal. Now, this line is actually dividing AB into two parts. What is that? AD and DB, isn't it? Yes. So the ratio would be AD upon DB. So we take that ratio. This ratio is equal to the ratio which is formed on that other side. That means we are saying that it is equal to AE upon EC, right? That is what is given. And we write the reason for this into bracket as basic proportionality theorem, right? Now, understand this. This theorem can only be applied in a triangle when we have a line parallel to a side. A line parallel to a side. So whenever we have a line parallel to a side, we can say that AD upon DB is equal to AE upon EC, and into bracket we write the reason as basic proportionality theorem. That means the ratios are equal. It could also be taken the reverse. If I take this ratio as BD upon DA, then the other ratio will be written as, yes, you are very correct, it will be CE upon EA. That is how we are supposed to write. Easy, right? That means we know this theorem can be only applied in a triangle whenever we have a line parallel to a side. Now let's see an example based on this. Observe here. In this figure, I'm saying that in triangle LMN, we have a line, I'm saying PQ, which is parallel to MN. This is what I'm giving. So can we apply basic proportionality theorem? Yes. And what is the ratio we get? Now let's write the presentation. So first we'll write the name of the triangle. In triangle LMN, we write this line PQ is parallel to side MN. Therefore, now write the ratio. What is the ratio? LP upon PM. LP upon PM is equal to LQ upon QN. And into bracket, we'll have the reason as by basic proportionality theorem. So isn't that easy? We always apply this in a triangle whenever we have a line parallel to a side. So let's see. I'll give you one more information here, right? We have another triangle here, XYZ, and I'm saying that there's a line here. This line MT is parallel to XZ. So can we apply basic proportionality theorem? Yes, we can apply. So let's apply it. So we write in triangle XYZ, we have line MT parallel to side XZ. So what happens? We get the ratio that is YM upon MX, right, is equal to YT upon TZ, right? And we write the reason into bracket as by basic proportionality theorem. So by now, you know how to apply basic proportionality theorem, right? And when to apply. Let's understand this. Let's give an example here. Now this is something which is very important. I want you to answer. Too easy. So we have a triangle here and I'm saying that line L is parallel to side BC. We want to find the value of X, right? Let's solve it. Well, you know that line is parallel to a side. So what are we going to apply? Yes, basic proportionality theorem. So let's write the steps. So we write the name of the triangle. In triangle ABC, we have a line L parallel to side BC. And so we get the ratios equal. So what are the ratios? We get AP upon PB. So we write that ratio AP upon PB. This ratio is equal to AY upon YC. And into bracket we have the reason as by basic proportionality theorem. Now substitute the value. The value of AP, how much is that? 4. The value of PB, how much is that? 8. value of AY is 3 and value of YC we don't know, that is X. So we wrote that. Now let's solve it further. We want the value of X. So, right, cross multiply. So we get X into 4 is equal to 8 into 3. Now keep X on one side. We'll get all the numbers on the other side. That is 3 into 8 upon 4. Do the cancellation, so easy. 4 ones are, 4 twos are, and 2 into 3 is 6. That means we get the value of X as 6. So we got the value of X as 6. That's the answer. We got the value of X as. Wasn't that easy? This is what we learned, how to apply basic proportionality theorem. So remember, it is always applied in a triangle whenever we have a line parallel to a side. Easy.